Hey guys, welcome back. So today we're working on this Generac XG10000E. These are very nice machines, brand new. They sell for about $2,500. Of course, this one isn't new. It is about 10 years old. That said, Jason still got a heck of a deal on it. He paid only $500. Of course, it's in non-running condition, but when you consider the amount of runtime on the clock, which is 0.2 hours, this is essentially a new machine. Now, the engine obviously hasn't seen much action, hasn't even been broken in, so it should run. That said, it doesn't run. Jason has done some work on it already. He put a new battery in, a new choke lever, and he fed some fuel into the carburetor. And although the engine cranks over fine, it's showing no signs of life. So likely it is a fuel issue. He already pulled the tank. He said it was in good condition, but the fuel in it was well past its prime. Thankfully, Generac still sells that carburetor. Unfortunately, it sells for $200. So Jason asked if I could take a look and see if I could save it. So that is the plan today. So let me get you set up a little bit better. We'll get this up on the lift and get going on it. So I'm thinking before we pull the carburetor off, let's validate the diagnosis here. So I'm going to extend this fuel line a little bit. We'll feed the carb some fuel, and we'll turn the engine over, see if we get any signs of life. Let's just double check the oil real quick. Yeah, plenty of oil. It's a little bit below full, but there is plenty to test with. Yeah, it didn't really take any fuel. So either the carb's already full or the needle and seat are stuck. So yeah, let's give it a try. All right, let's give this a try. We are full of fuel. Choke is on. And we get no signs of life. And we get nothing. No signs of life. So, we could throw a spark tester on there or a compression tester, but I say we just cut to the chase. We'll pull each of the plugs, put a little fuel directly in the cylinder, and try this again. Interesting. The plug, it is wet. Doesn't smell like fuel, though. Maybe oil. I'm not sure. And this plug is dry. Very interesting. Both NGK plugs, BPR 6HS. Bit of fuel in there. All right, let's try this again. This time we'll do choke off, and I've also added a light so we can see if it makes any power. Okay, that is all I needed to see. I mean, the engine sounds good and the generator is making power. The issue is the carburetor. It is not delivering fuel to either cylinder. So this, without question, has to come off and get cleaned up. It's been a while since I've cleaned one of these carbs, and they are a bit of a challenge, especially to uninstall. You'll, I guess, see when we get into it. But to get this off, we are going to have to remove these two screws right here, these two nuts, and then there's actually two more on the bottom. You know, once we get that out, the airbox should move out of the way, but then the carb won't actually come out until we remove the top studs. So once that's done and the linkage is disconnected, we should be free. So I'm going to start with these. They do look heavily corroded, or at least there's a lot of white powder on it. So I'll probably use the impact to try to break those free. So we'll just get these two off next. They're just a number 10. Just be careful because when these nuts come off, if you drop it in here, this is kind of like a funnel. It just drops it right into the carb, and that bolt can easily get lost. So I just pulled the choke closed. So right now the choke blades should prevent the nut from going too far down if I end up dropping it. The airbox is still on there pretty good. You know, we still have those two screws on the bottom, which are nearly impossible to show you. The governor linkage is in the way, but let me see if I can get in here. And yeah, I think I see a glimpse of one kind of right there. And the other one should be kind of in that area. So yeah, let me see if I can get you set up with a little bit better angle. And with any luck, you can kind of see what's going on here. We should be able to get this off now. There we go. Very interesting. The fuel solenoid wire is unplugged, and on most generators that wouldn't matter because the solenoid is normally open. You know, that way you can pull start it even with a dead battery. In this case, this one functions a lot like a tractor. You need a good battery to open the solenoid. So normally it's closed, and with this unplugged, that solenoid is closed. This engine would have no chance of running off of this carburetor. So, you know, I'm thinking we should try to plug that in and give this carburetor another shot. And what is this? Got some sort of linkage here on the ground. Interesting. The governor linkage is connected. Let's make sure it moves, and it does. So this actually looks like the rod that's for the choke. So when Jason replaced the choke mechanism, this looks like an extra rod that maybe just fell in. So we'll set that aside for now. And let's just finish getting this plugged in. Okay, let's try that out. Okay, well, no quick video today. I thought for sure plugging that in would solve the issue. And for sure, having it unplugged would cause an issue. But that is not the only issue. The carburetor is still not delivering fuel. So, yeah, let's continue on here. I did have to re-add these screws just to hold everything in place. So we'll get those back out, get these nuts off, as well as the studs. And at that point, we should be more or less free once we get some of these linkages disconnected. Just going to stuff this in the breather. I definitely see the nut falling off and going right down into the engine. So the next move here is to double nut this. So we're going to thread one on, and then we'll thread the other one on. We'll tighten them together, and then we should be able to use that to spin the stud out. We'll do the same on the other side. So before we proceed any further, I'm going to get this linkage off. This piece makes me nervous. It is plastic, and it's the only thing connecting the governor to the throttle plate. So, yeah, it seems like at some point that plastic's going to fail, and then you got big problems. All right, let's take a look inside this carb. So I'm going to get the fuel line out of the way. I also want to get this spring off as well. So I'm just going to mark it which hole it was in, although it seems to be fairly obvious. All right, spring is out. Let's crack the bowl drain, see what presents await us in there. Ooh. Well, the fuel doesn't look good. A bunch of debris came out. And it smells pretty bad. So there's a look at the fuel that came out, and it's pretty hazy, so I am willing to bet if I give that a few minutes, we're going to see some water in the bottom of that cup. So we'll just set it aside for now, and I'm actually going to start by getting off this fuel solenoid, and then we have 4 screws holding that bowl in place. Yeah, a bunch of junk on that pin. So this should normally be out and it should retract. It's not stuck, but it's definitely gummed up. So that for sure has to be cleaned. You know, as far as the bowl goes, these screws tend to strip out. So I'm going to try the impact just on a lower setting. Okay, a lot of junk, but I'm not seeing a lot of corrosion or rust. So that should clean up really well. You know, the float is not stuck. And we have two main jets right there. I believe it's one for each barrel. And those do look like they're clogged. So let's get this pin out. We'll get the float and the needle out of the way. And then we'll work on getting those jets out. All right, and let's see if these jets come out. Now, the last one I took apart, actually, a couple people commented that these are not the same size. So I don't know if that's true or not. I didn't really pay attention the last time. So this time, you know, I will keep track of them. And actually, before I even do that, I'll double check the size, see if they are in fact different. And we should have two emulsion tubes. There's one and the other. Now, I don't think there's anything more that comes off this carburetor. So, yeah, let's just go through the emulsion tubes, make sure they're clear. We'll double check the main jets. And actually, that one was not clogged, and neither is this one. So, yeah, it's surprising it didn't run. You know, I'm thinking just all that junk down there where the fuel solenoid was, and the fact that the solenoid is gummed up, you know, likely it wasn't opening. And even if it was, you know, it opens a little passage down there, and the fuel has to flow up through these two holes. So likely there was just a clog, or this was a little bit too gummed up. So, you know, I'm going to try to get these gaskets out of here, clean up the bowl, let this soak for a bit in the ultrasonic, and we should be good to go. All right, let's see what size this jet is. So this one, a 63 drill bit, almost fits. Let's try the next size smaller, which is a 64. And a 64 fits. So we'll check the other jet. 64 fits. And a 63 does not. So, yeah, these are the same size jet, which makes sense. You know, I'm not sure why you would ever jet each barrel differently, so we don't need to keep track of those. We'll just start with a bit of WD-40. It's pretty harmless compared to carb cleaner, and it does a really good job of cleaning stuff up like this. That is a lot better. And let's see if we can get these gaskets out without destroying them. Yeah, it looks like we're a little bit damaged here on this gasket. This is the airbox side, so it's not super critical that it's perfect. But we do want it to make a decent seal. So I think we can reuse this as long as we are careful when reinstalling this that the broken parts align. Of course, I might make it worse in a second here. Oh, there we go. So I was just testing the solenoid to make sure it was good, and was surprised actually, because when I energize it, I get a little spark, but that pin should be pulling in, and it's actually doing nothing. But if I energize it and push it in, it stays in until I disconnect the power, and then it pops back out. So, I actually think it's working the way that it should. The issue is that this pin, when it's not installed in the bowl, is allowed to come out too far. So if I install it in the bowl and just turn that in most of the way, we can then do the same test. And hopefully this time that pin retracts without any assistance. All right, so keep an eye on that. We'll touch it to the battery, and hopefully that pin pulls in. Yeah. Works fine. So fuel solenoid, not an issue. Cleaned up pretty well. So I think this carb should definitely run the engine. And I guess the question is, how well? So let's get it back together and find out. And last but not least, a fuel solenoid. All right, let's try it out. So I'm going to get the governor spring back on first. So we'll start with the carb side and then attach it to the governor arm. And once we've done that, I think I'm going to get the studs loosely in place to kind of hold things where it should be. And then we'll add the linkage that connects the throttle plate to the governor arm. We'll add a little bit of thread locker. Not sure it's really necessary, but the factory thought so. So we'll add it back. And we'll do the same on this one. So getting this airbox on, it's not an easy task. A couple things you got to keep in mind. First, there are no metal bushings here, so if you just crank down to tighten everything up, you're going to blow out this plastic. I've done it before. So normally I tighten carbs to about 70 inch-pounds. In this case, just snug them up. 70 inch-pounds will certainly break the airbox. The other problem is the breather. That has to get installed at the same time. And then of course we have these bottom bolts here. So there's a lot of things to kind of keep in mind when doing this. And yeah, unfortunately there is no easy way of doing it. So this might take a few minutes. All right, the breather's on. Just double checking the torn gasket, making sure the halves are in alignment. It seems like we'll be good. Now I'm trying to slide this forward. There we go. And definitely getting some resistance. Oh, there we go. Okay, good. So we're looking pretty good at this point. I'm just going to add the nuts and the screws. We'll leave them in there loose until we get the bottom ones in. Okay, good. Needle and seat are working, and it shut off the flow into the carb. So we are holding steady right there. So I think you know what's next. Place your bets. It's amazing the difference clean carb makes. This thing sprung right to life. I was able to turn the choke off right away, and the engine sounded good. And that was without the airbox fully assembled. So once that's closed up, it's gonna only run better. So I say we do that now. Let's get the rest of the airbox together. And I actually want to change the oil. The oil that's in there obviously only has 12 minutes of runtime, but it is over a decade old. And I don't know what kind of oil that is. Is it winter oil? Is it summer oil? Is it synthetic? Or is it mineral? And for something like this that has not been broken in, it shouldn't be synthetic. So I'm going to drain that out. We'll put some fresh conventional oil in, and then we should be ready to get this thing outside. I think we can safely put the airbox back together. So this label was missing, and actually a lot of people don't even know that it exists because the fuel tank is usually covering this up. Now, if you're running in the winter, you risk your carb icing up. And a lot of generators don't have this feature, but if you do, you want to flip it to winter mode. And what that does in this case is it moves a shutter, so it's now taking the fresh air from right here. There's supposed to be a pipe running down to the exhaust, and it's not connected to the exhaust, but it takes heat off of the exhaust pipe and sends it in to the airbox and through the carburetor. So that keeps the carb from icing up. Now, this pipe is missing, so I'm going to ask Jason if he has it. If he doesn't, we will have to order one up. For now, we'll just leave it in summer mode. It's a good thing we're changing this. That oil consistency looks pretty bad. It's shocking what just came out of there. When I first pulled the cap off, the oil that came out looked watery and chunky. That was followed by a bunch of metallic and froth. So yeah, this oil is no good. It's definitely breaking down, so it is a good thing that we are changing it. Now, I didn't buy an oil filter. I didn't really expect we would need to change it after 12 hours of runtime. So for now, I'm going to get fresh oil in there. We'll put some more time on the engine with the good oil, and then we're going to have to flush it again and put a new oil filter on. Now, the shocking thing is that Generac recommends the first oil change after 30 hours. And of course, this is about 12 minutes of runtime. So yeah, running with that oil would not have done this engine any good. Anyway, let's get the cap back on. We'll get some good oil in the machine and move on. Perfect. We are at the full mark. And last but not least, we do have some damage over here. This circuit breaker broke both its arms off, and right now it's in the off position. So to reset it, you actually have to move both of these at the same time. So technically you could reset this and likely it would work fine, but it should really be replaced. It should look like this one up here, which operates just fine. Now, luckily, Generac is one of the few manufacturers that actually supports their stuff and they sell parts. That part, it is still available. Now, guess how much that circuit breaker costs. How much do they normally cost? Usually around $15, maybe $20. Well, in this case, you might want to sit down because the price for this circuit breaker is $290 plus tax and shipping. At least from the site I looked at, if you shopped around, maybe you could get it for closer to $200, but that is still way too much. So I am not in a big rush to do that. Thankfully, I did find an aftermarket one available on eBay. It is the correct form factor and the correct rating as far as I can tell. And that one was only $30. So it's been ordered and it should be here in a few days. All right, the new circuit breaker showed up today. This one was the $30 one from eBay. And, from looking it over, it seems to be the right form factor. So I think it's going to go in there okay. But before I install it, I do want to check the resistance of this circuit breaker. I've received a lot of circuit breakers brand new out of the box where the resistance is higher than it should be. So I want to make sure this one is low before installing it. And assuming it's good, I guess the second issue might be the fact that it came with no hardware. So hopefully the thread is the same on these fasteners as what this one expects. All right, so right now the circuit breaker's off. I've got this set to measure resistance. And like this, we should not measure anything on any of these tabs, and we don't. So we're off to a good start. Guess we'll turn it on. Now the value on this should be really low, less than an ohm for sure. And yeah, we're at 0.2, 0.1, which is perfect. These leads, the built-in resistance is actually 0.1, so that is a very good connection. Of course, we shouldn't have anything connected over here, and we don't. So let's move this probe over and check the other leg. And same thing. Nice low readings. So this breaker seems to be good. So to get access to this panel, we just need to remove these screws going around, and it should pull forward without too much issue. And I have opened these before. These are definitely a bit of a rat's nest of wires. There's a lot going on in here. Thankfully, we don't need to touch much of it. And yeah, definitely a rat's nest. Anyway, the one we're after is the one right here. And yeah, I think it's going to be a little tricky to gain access to this without getting carried away and removing a whole bunch of stuff. So, I'm thinking, let's remove the screws on the front. Potentially we can pull that out and get a little bit better access to these screws holding the wires in place. And I know for a fact we're going to have issues already. Yeah, I just tried those bolts that were holding this circuit breaker in place on the new circuit breaker, and of course it's a different thread. So I'm just going to remove this one screw. Let's just try it on the new circuit breaker, see if it fits. No, it's close, but it's not the same. So yeah, until we get the right hardware, we're kind of dead in the water here. All right, it took a while, but I managed to scrounge up 4 screws that seemed to fit just fine. And on this side, it took a long time to find something that fits this. This is just a tiny little screw. Anyway, I have a total of 3. I actually stole them from these toggle switches, so that should be enough to at least get it installed. You know, I will have to make a trip to the hardware store just to get the 4th, but that shouldn't hold us back. I think we struck out on this one. The original circuit breaker, trip amps 37.5, and on the new circuit breaker, although it was advertised as a direct replacement for this, you can see the trip amps is actually 47.5. So yeah, that, although it might fit, it's not going to work. Well, it's been at least a week, and I've been hemming and hawing about what to do about this. The other breaker, the one I got from eBay, that one was returned, and thankfully I got my money back on that, but it doesn't solve this problem. You know, thankfully the part is available, so if I was desperate, I could order it. And after shopping around, I did find a cheaper option at $200, but still, when you factor in tax and shipping, it's at least $230 for one circuit breaker. So yeah, I just couldn't do it. So instead, I went to the manufacturer's website, Carling Technologies, and they make a ton of switches. So it took a little while to locate what series this was, but it ended up being an A-series switch, and there was a decoder for the A-series switches or circuit breakers. So, you know, I ran this number through, and unfortunately it did not decode properly. It indicated that this was a DC breaker rated at 0.5 amps, which it's not. So I was kind of down, considering again buying the Generac part, and actually stumbled upon one on eBay. For $200, it was the correct Generac part number, but I noticed the Carling number was completely different. So I ran that through the decoder, and thankfully that decoded properly. So from that, I was able to locate a suitable replacement. It wasn't identical. I mean, electrically it was, but there were some differences on the outside. So I ordered one from Mouser for $75, and here it is. So it is correct as far as the specs go. The big difference is that the switches are white, the screws here are metric instead of imperial, and the connectors on the back, they're spade connectors, whereas the original were screw-on. So that's really the biggest difference, is that the control panel has ring terminals that we have to cut off and put spade connectors on instead. So I went to install it and actually found that we were missing a part. You know, we have these plastic pieces right here that bridge the 2 poles, and we also have this metal pin that is held on by an E-clip on each side, and one of the E-clips was missing. So I reached out to Mouser and asked if they could send me another clip, and they agreed. And surprisingly, they sent me a whole other switch free of charge with said E-clip. So yeah, pretty impressive. You know, if anyone's ordered stuff from Mouser, you know they're a great company, and this just goes to show it. So let's retrofit the wiring and get this installed. we need to cut these ring terminals off. So we have two here. This is actually on the load side. And then we have two pairs over here. I actually zip tied them together so I don't get them confused. I will leave those alone for now and just cut these ring terminals off. And then we'll strip the wires back and put the spade terminals in their place. I'll do one more. Give it a good pull. You want to make sure it's on there nice and tight. So that one seems fine. These are also shrink tubing, so we'll shrink those down once we get all 6 wires converted over. Okay, those two are good. Now for these over here, I do need to do something different. These ring terminals were doubled up with the one screw holding them kind of to the circuit breaker. And with the spade style, you only have the ability to put one spade on. You can't double up unless you get a different type of spade connector. So I picked up some piggyback connectors. They're very similar to this one right here in that they connect to the spade, but we also have this piece here, which will allow, a second wire to be connected to the same spade on the back of that circuit breaker. So yeah, I'll just cut these zip ties out of the way and we'll strip these back and attach a couple of these. All right, that one's good. I guess I should have double checked this. There's not a lot of room back there. So, these screw terminals are fairly shallow, whereas the spade connectors are going to go quite a bit further before making their bend. And yeah, hopefully we have enough clearance in the back. I guess worst case, we could probably bend these a bit sideways to get a little more wiggle room. Okay, 2 more to go. This wire is thinner than the others. The other wires were 10 gauge, and these connectors are good for 10 and 12. And it looks like a 12 gauge to me, so we'll try the same spade connector terminal and just make sure we have a good tight connection on that wire afterward. Yeah, that seems fine. So everything's connected. So let's add the circuit breaker. We'll try plugging everything in and then fitting the control panel back in. Just going to test fit everything before I secure it. I'm really worried that the length is going to be a problem here. So I'm not going to shrink the shrink tubing quite yet until I'm sure this is going to work. Yeah, I think it's going to be fine. There is some pressure in the middle, but there's actually a lot more on the right. And that's been my experience with these control panels. Everything is really packed tight when you put this control panel on. It could have really been a little better if they'd made this control panel maybe half an inch deeper. So, yeah, I think this is going to be fine. So let me get these spades back off. We'll shrink down the tubing and then finish this up. I'm just double checking the breaker to make sure we have a nice low connection in this 30 amp outlet. And as you can see, we do. It's at 0.4 ohms. And if we flip it off, that goes away. So the new breaker seems to be good. All right, let's give this a try. I've got a couple multimeters hooked up. The one on the left, we'll just double check the 30 amp out. You know, right now I'm plugged into leg 1, so we should see 120 volts out of that. We'll check leg 2, and then we'll do from leg to leg, which should be 240 volts. This meter here is connected to the battery, so I believe this one actually charges the battery. So we're starting at 13.24 volts, so we'll double check that once the engine started. Now this is rated at 10,000 watts, and I'm a little bit hesitant to do it, given that the engine's not broken in. We're only at 0.2 hours. You know, that said, I do want to make sure that the carb is fully fixed and can handle the load. So, you know, I'm going to get it started up. You know, we'll double check the outputs, and then we'll bring a 6,000 watt load on. You know, see how it does, and then we'll bring it up to 10,000 watts just for a brief time to make sure the engine and the carb can handle it. All right, so far so good. Although the engine, I do hear it stumbling once in a while, so I'm thinking we do still have some carb issues. As far as the THD goes, you can kind of see the problem here. You know, the THD is at 3%, but when the engine speed changes or fluctuates, it jumps up quite a bit. You know, right there I just saw 8 point something. You know, the sine wave looks pretty good. And if you look at the Hertz meter right here, you can see it bouncing around. So let's bring on a 2,000 watt load. Seems fine. 4,000 watts, no problem. Let's go for 6,000. And no, we've got a pretty good surge going on. Although it is slowly working itself out. Should we try 8? No, that's pretty bad. So we do still have issues either with that carb or potentially the governor linkage. So I'm going to let the engine cool down a bit. We'll shut it down and take a closer look. Well, I wouldn't say that was the result I was hoping for. You know, I could tell after the engine started and I turned the choke off, the engine speed was a bit unsteady. And you could really see that in the THD numbers. They were fluctuating between 3 and about 10%. And you could see it also in this needle. So my hope was it would get better under load. And unfortunately, we reached a tipping point at 6,000 watts. It just wasn't getting enough fuel to hold the engine speed steady. So that carb, unfortunately, needs to come off again. We need to go through it and figure out what was missed. You know, I guess on the good news side, the circuit breaker is working fine. You know, all the outputs on this 30 amp plug tested as they should. So at least that issue is sorted, but we do need to figure out this issue. Actually, before we bring this inside, you know, the oil's nice and hot. And of course, the last time we changed it, we saw the oil quality was pretty bad, and I didn't change the oil filter. So there is still some bad oil in there. So I'm going to flush it out right now. I do have a new filter, so we'll throw that in as well. And at that point, the oil should be good until the break-in is done. Back here again, just double checking my work, and things look pretty good. You know, everything's nice and clean, although a bit of debris did come out when I drained the fuel, so potentially that was the source of the issue. You know, the main jets, the emulsion tubes, they are nice and clear. I mean, they were actually clear before I cleaned the carb, and they are still clear. You know, that said, I don't think it's related to the main jets. You know, these only come into play when the machine's under load and the throttle plates open up. You know, when the plates open up, it creates a strong vacuum inside the carburetor where it can then pull up the fuel through the emulsion tube. But we had issues at startup. You know, it ran rough, it surged a little, and even without a load, the engine speed was not steady. And, you know, even though it was running at 3,600 RPM with no load, these plates are virtually closed. The only fuel really coming in are through these little holes right on the top. And if those are blocked or not providing fuel, then you're going to have issues from no load, up to a full load, because the engine's going to be underfueled by a clogged pilot system. And if you remember back when I had this apart, I didn't see the pilot jets. Well, this time I found them. They're right here underneath this washer. I saw this before. I actually just thought it was something holding this fuel pipe on, but that's not the case. There are two kind of Honda-style plastic pilot jets underneath that washer, and it's held in place by this proprietary fastener. So I was going to get a Dremel and just kind of slot that out and use a screwdriver to remove it. But before I even do that, let's just try it with a pair of pliers. If this isn't too tight, that might save a bit of time. Oh yeah, it's turning. It's actually quite loose. So there's just a lock washer under there. And kind of makes sense. You don't need to have this tight. Why they chose that fastener, I don't know. And there they are. So I'm pretty sure if we just clean out these jets and blow a bit of carb spray through here, then I think we'll be back in business. These jets are so small, it's really hard to tell if they're clogged. But this one, I do see a little sliver of light. So I don't think that one is clogged. And then we have the other jet, which... yeah, I think it's open. So I don't think the issue is with the jets. I'll run a wire through them just to make sure. But on the bottom is where it picks up the fuel, and it actually goes straight down through this body right here. There's a couple of kind of small channels, off the main area that draw the fuel up. And I'm guessing just one or both of those channels got clogged. So if we take carb spray and just blow down through those holes, we should see it exiting down here, if things are open. So let's give that a try. All right, that one's good. And so is that one. So besides those passages, we also have these passages here that run over to those little holes actually on this side. So what I'm going to do is block off right here, and we'll spray again, and we should see it coming out right there in the throat of the carb on each of those blades. It's going to be a little bit harder to do than I initially thought. If I just block off down here and spray in here, ideally we would see it come out right there. But, this is a large cavity, so I really need to build pressure to get that to work. So what I'm going to do instead is block both the bottom and the top, and then I'm going to spray in right here. This is where it picks up air. That air is combined with the fuel and mixed, and then it enters the carb right there in front of the throttle plate. So if those two are blocked and I spray here, it should come out right there. I found these little rubber plugs, which should make this a lot easier. All right, that side was clear. Just move the plugs over and try the other side. The carb passages are all clear. There didn't seem to be any major obstructions, so yeah, I'm still not 100% sure on this. Yeah, this one actually did feel a little bit crusted up compared to the other one. Okay, so I'm going to pause it. We'll get this back together, and we'll try it again. All right, let's give this another try. Same plan as before, hopefully a different result. So I'm going to get the engine started. We'll double check the outputs. If all is well, then I'm going to put a half load on of 5,000 watts and double check the output. If things continue to run well, I'm going to slowly bring the load up to the max rated of 10,000 watts. So far, so good. The engine started nice and easy, no surging. So let's just double check the THD. It's about 3%, but it is fluctuating a bit. And the sine wave looks pretty good. So let's try a 5,000 watt load. That's 4,000. 5,000 watts, things are running pretty well. For a 3.9% THD and the sine wave, cleaned up a bit. It looks pretty good. So I'm going to give it a couple of minutes, and if all goes well, we'll start to bring it up to the max. All right, no issues to report. So let's take off 1,000, swap it for a 6, or a 2 rather. So we have a total of 6,000 watts. It's handling it just fine. Let's try another 2,000, so it'll be 8,000 watts. It's doing fine. 9,000, 9,500, 10,000 watts. It's doing it. THD is only 4.2%, and the sine wave continues to look pretty good. It's been a couple minutes. No issues to report. It's pulling just over 40 amps. Engine speed is fairly stable, and we don't have any surging. So I think that's a pass. So I'm going to take the load off. We'll just let the load bank and the generator cool down a bit, and then we'll shut everything down. Just double checking the amps
And at 240 volts, it's rated at 41.6 amps. And that's pretty much what we got. So yeah, not too bad. The hour counter is still just below an hour. We're at 0.9 hours. Anyway, this time, much different result. You know, it started without issue, could turn the choke off right away, no surging, the engine speed was stable, and we had no issues getting to the max rated of 10,000 watts. And best of all, THD, very clean on this machine. It topped out at about 4% THD, and you don't see that on many portable generators unless it's an inverter. You know, this one is one of the cleanest I have tested. So, you know, if that's something that's important to you, this is definitely on the short list for clean running machines. Anyway, I hope this video helps someone. Thanks for watching.